This video will introduce the topic of the quadratic formula, and the learning outcomes for this topic is to use the quadratic formula to solve quadratic equations, to use a discriminant of quadratic equations to determine the nature of its solutions as well as its graph. When I teach college algebra in a face-to-face class, we derive the quadratic formula together using the completing the square method. If you are interested, you are more than welcome to view a separate video I found on YouTube doing the derivation. I am sure most of you are familiar with the quadratic formula as x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. I do the quadratic formula a little differently, but very effectively using the discriminant. I will show you my method, and you are more than welcome to use the formula the way you know best. Before we can use the quadratic formula, we need to make sure that our quadratic equation is in the standard form ax squared plus bx plus c is equal to 0. Once this is done, I like to look for a, b, c, and big D, where big D is b squared minus 4ac. It is denoted with the capital letter D and represents the discriminant of the quadratic equation. Now I am able to substitute the values of a, b, c, and big D into the formula x is equal to negative b plus or minus the square root of big D all over 2a. I am not sure if my math lab will allow you to enter the plus or minus. In any case, note that you will get two answers depending on the value of D. Your answers are in the form of the solution set of negative b plus the square root of big D all over 2a, and negative b minus the square root of big D all over 2a. I stated that your answers depend on big D, the discriminant. If big D is a positive number, D is greater than 0, we can take the square root of big D and get real values. If big D is a perfect square, such as 4, 9, 16, 25, etc., when we take the square root of big D, I will get a whole number. This means that our solutions for x will be two real and rational solutions. However, if big D is not a perfect square, such as the number 5 or 12, we can still get the square root of this number, and it will be an irrational number. This means that our solutions for x will be two real and irrational solutions. If big D is 0, our quadratic formula reduces from x is equal to negative b plus or minus the square root of big D all over 2a to just x is equal to negative b over 2a. This means that our solution for x will be one real and rational solution, the value of negative b over 2a. If big D is a negative number, where D is less than 0, we can take the square root of big D, but we have to use our knowledge of complex numbers to do so. If big D is negative 16, when we take the square root of big D, and we get a whole imaginary number, in this case 4i. This means that our solution for x will be two complex and rational solutions. However, if big D is not a perfect imaginary square, such as negative 12, we can still get the square root, and it will be an imaginary irrational number. This means that our solutions for x will be two complex and irrational solutions.